Welcome to a video tutorial about MapForce PDF Extractor. PDF Extractor is a MapForce utility which enables you to define the structure of a PDF file and extract its data. PDF Extractor is a highly flexible tool. It enables you to extract only fragments of text instead of the whole document. It also allows you to mix and match pieces of information from different pages of the same file, split tables into rows, and arrange data in groups. You can also use various methods of locating split positions. Once you're done with your template, you can add it together with a PDF file based on this template to MapForce and map PDF data to any other format. PDF extraction templates are particularly useful when you have a big number of PDF files with the same or very similar layout. Applying the same template to multiple PDF documents will help you automate your business operations and make PDF data extraction easier and faster. In the first part of the tutorial, we will show you how to create the PDF extraction template and use the automatic table suggestion to extract table structure and data. We will also explain how to define other extraction rules manually. In the second part, we will explain how to import the template into MapForce and map PDF data to a JSON file. You can run the PDF extractor directly from MapForce or from the Start menu. We have launched the extractor from the Start menu. When we open the PDF extractor, a new template is created automatically. Now we need to load our PDF file based on which we will define extraction rules and from which we will extract data. Our sample file is an invoice that has 2 pages. The company sends a big number of such invoices to its customers. Therefore, we want to create a template that will help routinely extract PDF data from these documents. The invoice has the following layout. The company invoice and client details have the same positions on both pages. The invoice also has a table that contains order details. The table spans across 2 pages, and there is also a disclaimer at the bottom of the second page. To load our sample document, let's click Open in the PDF View pane and select the relevant file. Let's also make our file a bit bigger. As soon as we open the file, the suggestion engine identifies tables on both pages. We will use the table suggestion on the first page and deal with the second page a bit later. To use the suggestion, let's double-click the table label. As you can see, the table structure and data have successfully been extracted. The schema pane displays a tree of objects which define how PDF data will be extracted. The top node is the root element with a default name document. Under the root, we have a group filter object which processes the first page of the file. Note that you can easily check and change the properties of any objects in the properties pane. Under the group object, we have 2 vertical anchors that mark the beginning and end of the table. These positions have been identified by the algorithm. Besides, we have a split object which specifies how to cut the table region into rows. For this example, we have selected the Find Lines or Edges method. This method searches for lines along which the region will be cut. You can check these split positions in the PDF View pane. To see the result of splitting, we will click the child object, which is the group object in our example. The group object contains several horizontal anchors and text captures. The horizontal anchors delimit the table columns. Each text capture in this group defines the position of a particular column and shows its name. At the same time, we can see an XML tree with data in the output pane. The output pane displays the result of extraction. This is very useful because you can check if you get the desired result, and if not, you can always tweak the extraction rules accordingly. Since we accepted the table suggestion for the first page, the extractor created a group object for this page only. This helps avoid unexpected results from unrelated pages. The second page is currently grayed out. You can always edit or remove the group object if you want to apply the table structure to other pages. To apply the group object with all its children to all the pages of our document, we need to remove the index from the Select Groups property. Now let's check the group object under the split. As you can see, the split results now include data from both pages. We already have pretty good results, but there are some fragments we want to exclude. In the next step, we will get rid of the vertical anchors. Vertical anchors are constant assignments that are fixed on all the pages they apply to. These vertical anchors correctly delimit the borders of the table on the first page, but they do not correspond to the dimensions of the table on the second page. Instead of the vertical anchors, we will use a vertical boundary finder that searches for table borders dynamically. Let's right-click the top vertical anchor and select Insert Before, and then Vertical Boundary Finder from the context menu. Next, we need to change the default names of the start and end to Table Top and Table Bottom respectively. This way, we will preserve the correct references in the region property of the split object. Now let's check the table borders. We can see that the algorithm has correctly identified them on both pages. We can now delete the vertical anchors using the Delete key. Our next goal is to exclude some fragments of the table from processing. In order to do this, we will configure the split object. PDF documents may vary considerably, and you may need to test different approaches to find the best settings. To eliminate the fragments we do not want, we will first experiment with the skip initial and skip final properties. These properties specify how many initial and final snippets of the split region will be excluded. Let's keep one initial snippet and one final snippet. Since we use the Find Lines or Edges method, the algorithm has identified the first line in the location where the header row ends, and has excluded everything above this line. To clearly see the split positions, let's zoom in using the Control key and the scroll wheel. The red dotted line has been identified but not used by the algorithm, and the blue dotted lines are the actual split positions. As for the bottom fragment, the same logic applies here as for the skip initial property. Now let's take a look at the second page. We use the same settings for this page, but unfortunately the results are not satisfactory, as we still have some fragments that haven't been excluded. The best solution to this problem is to use the minimum extent property, but first let's set the skip initial and final properties back to 0. By experimenting with different values, we have found an ideal value of the minimum extent property, which is 30 pt. All the fragments smaller than this value will be excluded. Let's go back to the first page. Let's also check the split results. We can see that all the unwanted fragments have been excluded. Actually, the second column in this table has two types of information, part numbers and descriptions. We would like to have these bits of information separately. The simplest solution is to copy the second text capture and then adjust the size of the cells. We will right-click the second text capture and click Copy. Then we will right-click this text capture again and select Paste Before. You can also use the standard Windows hotkeys. Now we need to rename these text captures to avoid confusion. Then we will click the description label in the PDF view pane and adjust the size of the rectangle. When we modify the size of the rectangle, the changes automatically apply to all the cells in this column. Let's do the same for the part number capture. Next, we need to give meaningful names to the group object and other text captures. This will help us better organize our data. The name of the group object will be item. Let's continue changing the other names. This is how the tree now looks in the output. Now we are ready to work on the head of our document. We will define extraction rules for this part of the document manually. First, we want to capture the invoice number. Let's select a rectangle that includes the invoice number. And we need to make sure the rectangle is big enough because invoice numbers may become longer over time. Otherwise, our data may get truncated. Then we need to right-click the rectangle and select Create Text Capture from the context menu. The extractor will ask you if you want to apply the newly created text capture to the current page or to all the pages. In our example, we want this text capture to appear only on the first page. If we select all the pages, we will get the text capture on each page and multiple instances of the capture in the XML tree. After this, a new group with the text capture appears at the bottom of the tree. You can always tweak the group object to include other pages as well. The logical position of this group is at the top of the page, so let's place the group under the document node. The name of the group will be header, and the name of the text capture will be invoice number. We have created some other text captures, and now the header looks as follows. Let's also check the result in the output pane. A useful tip is to click elements or their values in the output pane to see what objects they refer to on the page. As for the customer details, we will treat them as one unit of information for simplicity. After creating a text capture for the customer details, we can see this information in the output. We assume that the company details will always stay the same, therefore it doesn't make sense to include this information in the template. Besides, our template will not include text captures for the tax and total price, because it's quite easy to calculate these values in MapForce. Our template is now complete, and we can import the template and the instance file into MapForce. In the second part of this tutorial, we will design a mapping that will read data from our PDF file and write this data to a JSON file. Besides, we will supply information about the last update and also calculate the total price of all the items. First of all, let's insert a PDF component. MapForce will ask you if you want to use an existing template or design a new one. We will import the template we created previously. Now let's check our instance file in the component settings. To check the settings, we will double-click the component header. The name of the input file is correct, and we can go on with our mapping. The next step is to add the target. The target component is based on a JSON schema. Let's add this file to the mapping. Now we need to map the source nodes to the target nodes. The next step is set the now function that will tell us when the mapping was last updated. Let's double-click an empty area and start typing now. Then double-click the function. Next, we will connect the function with the last updated node. The last step is to calculate the total price of all the items. In order to do this, we will add the sum function. The values parameter will receive data from the extended price element. Let's map the result of the function to the total price node. We are now ready to see the result of the mapping. The output informs us about the last updated order details. And we can also see the total price of all the items in the order. You can test all the MapForce features yourself. Simply download the fully featured 30-day free trial from the Altova website.